Good morning, students. So in this video, we'll be doing exercise 7.7, question number 12. This is the question that is given, okay? We're asked to integrate the function. But since I think you're already aware of this, in order to see, I think you've already done this, but for all the other exercise, or as far as exercise 7.7 is concerned, there are three formulas that you actually have to learn, right? So for the other question, that is from question number 1 to 11, these were all the formulas that you were making use of it. So even for this problem, you need to make use of these three formulas, okay? Without which integration is going to be difficult, okay? So remember these three formulas, okay? You have to remember it, and this will help you remember. Without this, you cannot proceed with this problem at all. So this is the first formula that you have to remember, okay? These are the three formulas, which actually, if you refer your textbook, it's there in page number 329, okay? Nbse page 329, okay? You just refer the formulas that you see in bold letter. Those are the formulas that you will need for this problem, okay? I'm using an old textbook, but I hope it's the same. But it's just before exercise 7.7. So this is kind of like the formula. It's not that difficult to remember it, okay? It's a fairly easy formulas, so you'll definitely have to remember all of this, okay? And then I'll give you a little explanation about these formulas, okay? So for question number 12, 13, 14, all these three questions, we will make use of this formula, okay? So I think you have done enough of it. So these are the three formulas that you have, okay? Suppose you have an integration of this form, integration x squared minus a squared in the sense it's a constant. Remember this, okay? It's a constant. The a's that you see is a constant, okay? X squared minus a constant square. Then you can, instead of solving that integration, you can just use this formula, okay? X by 2, x squared minus a squared, and so this. And in case you come across this problem, you can always use this. See, there is nothing much different between this and this, clear? This is x squared minus a squared. Basically, it's the same thing. Only what happens is under the square root, this is x squared minus a squared. In the case of this, since this is x squared plus a squared, it becomes plus. Since this is minus, you just put a minus over here. You just have to put a plus here over here because this is also plus. Okay? There's nothing much difference. It just changes because of the sign. So this, if you remember this, it becomes very easy to learn the plus one. Okay? You learn one of this, it becomes very easy to. It becomes easy even for the other equation. Now the third one, it's a constant square minus x squared. In case you come across an integration of this form, then you'll have to use this formula. All right? So, okay, so these three formulas are very, very important. Okay. Clear? Now we shall go with the first problem. So for this problem, what we usually do is we have to take a procedure, okay, where we take our x in the sense, okay, it's usually like this. Whatever function comes outside, okay, whatever function comes outside the square, you're supposed to take that, okay, clear? Sometimes you'll come across x plus 1, which we'll be doing in question number 3, but whatever functions or whatever variables, okay, it comes outside the square root, you're supposed to take that and equate it to a into differentiation of whatever is inside this, okay, whatever is inside this given equation. That means, okay, under the square root. So under the square root, this is the quadratic polynomial that's under this square root, so you have to consider that. Okay, this is a quadratic polynomial because it's of the form ax plus b plus c. Okay, after this, you take a, then differentiate this. I hope, okay, differentiation of x is going to be 1. And differentiation of x squared is going to be 2x plus b. Okay, I will not be teaching differentiation really in detail because we've already done we've done exercise chapter 5, chapter 6, all of that, and it was dealing with differentiation. So after this, what you're supposed to do is we have to equate the coefficient of x, okay, the coefficients of x, and constant term on both sides, okay? Constant term on both sides. So first, let's just try to solve it. So you get x is equal to, you open up the bracket, you get this as a plus, I'll write this as 2ax, okay? So I'm multiplying a into 1 and then plus a into 2x, okay, after that plus b. Now you tell me what is the coefficient. See, we have to equate the coefficient of x not just on one side, on both the side. Clear? So what is the coefficient, what is the coefficient of x on the left hand side? It's 1, right? This is going to be 1 equal to the coefficient of x on the right hand side is just 2a. Okay, so this is what we get. Now what are the two constant terms? What is the coefficient or what is the constant term on the left hand side? Nothing. Okay, you just have, can take this as x plus 0, so it's going to be 0. But what are the two constant terms that you see on the right hand side? It's a plus b. Okay, this will help us to find out the values of a. So half, okay, so a becomes 1 by 2 and b is nothing but minus a, so b becomes minus half. Clear up to this much? This is how you have to do it, all right? After you're done with this, therefore your x becomes, okay, equation x, replace a with half, so half into 1 plus 2x, and replace your b with minus half, so it's just going to be minus half. Clear? So this is what we have for x. Clear? Now we shall go with the integration, okay? Therefore, we are asked to integrate x of root over x plus x squared. Yes? So what is integration of x? What is the value of x we found out? We found out that x is half of 1 plus 2x minus half. I think this is what we got. Yes? Yeah. So just put a bracket over here. See, remember this is x of root over x plus x squared. Okay? Differentiation. Okay? You can write this as integration I. Okay? Capital I. Now you just open up the bracket for this. So once you open up the bracket for this, you get this as half into 1 plus 2x root of x plus x squared. Let's take them apart, dx, okay, minus integration of, now since there's a minus, so I've put a minus here, and you can just take the 1 by 2 outside, okay, it's a constant term, so you can just take it out, 1 by 2 into root of x plus x squared. Okay, so what I'll do over here is I will write this, I'll take out all the constant term, okay, and we'll do one thing. Okay, this is x of dx. I'm just taking out the constant term 1 by 2, okay, x plus x squared. So what I'll do over here is I will take this integration as I1, okay, and I will take this integration x plus x squared as I2, okay, in bracket, just for your understanding, I1 actually means integration of 1 plus 2x of root over x plus x squared dx, okay. I've just taken this. This is just for you to understand, okay. You don't really have to write this. If you understand, even without this explanation, then well and good, okay. I've just replaced instead of I1. Now let's work with I1, okay. So let's go for I1 for the first integration, okay, which is actually let me just go back and keep on checking. For I1 it is integration of 1 plus 2x of root over x plus x squared dx. So for this, what you actually need is, we'll do this by substitution, okay. So what I'll do here is you have to think about this. I'll take x plus x squared equal to t. Now let's differentiate this. If you differentiate x, you get this as 1. If you differentiate x squared, you get this as 2x. And you put a dx over here and you get this as dt. Alright? Okay. Now what you can do, what do you understand by this? Therefore, 1 plus 2x into dx is what? It is dt, right? And what is x plus x squared? X plus x squared is nothing but t. Okay? Remember there is a root, so you'll have to put a root, okay? Root t. Now, let's integrate this. T root can be written as 2 to the power half. Yes? So t to the power half would be t 3 by 2 divided by 3 by 2, okay? Because remember, integration is half plus 1 and half plus 1. So this will give you, because of this you'll be able to get this as t to the power 3 by 2, 3 by 2, okay? Next, 2 will go to the numerator, 3, so t to the power 3 by 2. Alright, now replace your t. Our t, we have taken it as x plus x squared, so you have to replace it. Remember, integration or differentiation, anything of the sort, if you use substitution method, remember your answer should always be expressed in the x form. So this is what we got for I1, okay? Next, let's work for I2 simultaneously. So this is for I2. For I2, you have this as integration of root x plus x squared of dx, okay? So for this, what do you need over here is, just as you have done in the previous question, you'll have to make some few changes. Okay, so you can write this as, if I write this as x square, okay, x square, and I add with plus half into 2x, what do I end up getting? I do end up getting x itself, right? Plus 1 by 4 minus 1 by 4. Okay, this is something you have to think a little bit, okay, but I'm pretty sure if you do exercise 7.7 properly, then this should not really be an issue. Okay, now you look at this, you see, you equate this x square and you cancel out 2 and 2, and 1 by 4 and 1 by 4 will cancel out. So once you start cancelling all of this, you'll end up getting x plus x square. But what is the formula for this? X square plus half into 2x plus 1 by 4. This is the same formula as x plus 1 by 2 the whole thing square. You expand it. When you expand it, you'll be getting this as a square plus b square plus 2ab. So x square plus b square. So 1 by 2 square, which is 4, into 2 into ab. So 2 into your a is x and your b is this, minus 1 by 4. Okay. So this, you will get this as x plus half the whole thing square minus 1 by 2 the whole thing square. Okay. There's other tricks for finding this out, okay? So you can make use of that. Maybe in the next question, we'll try to make use of those tricks, okay? But oftentimes, in exam, we do not remember all those tricks. So you just have to sometimes think a little bit about this, okay? So this is what we have, okay? Now, if you observe carefully and refer to those 3 problems or the 3 equations that I gave you, this is actually in the form of integration root over x squared minus a squared. Do you agree or not? Okay, it's actually in this form, integration of x squared, where our x is x plus half the whole thing squared. So now, since this is in this equation, okay, you can always say, let's take, okay, no problem, okay. So I hope you're okay with this. Okay, so if you want, you can always take the differentiation. Okay, so you can just say let's do one thing, you will take x plus, in order to clarify the doubt. So I'll just take this as t, differentiate this. So I'm taking x plus 1 by 2 is equal to 2. So differentiation of this will just leave you with 1 into dx. Differentiation of 1 by 2 is going to be 0 and dt. Okay, therefore you can always replace your I2 as integration of x plus half is the same thing as t. So you can take this as t square minus 1 by 2 the whole thing square. Your dx can be replaced with t. Remember, when you make substitution and when the moment you transform t over here, this also has to change, okay? You cannot write this way. You cannot write t square minus half, and you cannot you cannot leave dx unchanged. If you change this given variable x you substitute it with something, then the differentiation of this differentiation should also change, okay? So this actually means differentiation with respect to x. So our variable should also be x over here. This is differentiation with respect to t, so our variable should also be a t here, okay? Yeah, so this is what we're getting, and this is the same thing as x squared minus a squared. So we'll be making use of that formula, okay? So I'll just write again over here. So t squared minus 1 by 2 the whole thing squared dt. So let's make use of that formula, okay? I'll directly use that formula. So when you use this, what you'll get is x by 2 is the first thing, so you're going to get this as t by 2 root of t squared minus 1 by 2 the whole thing square, okay, minus, what is a square? Your a over here, this is x squared minus a squared. So your a is 1 by 2, so it's a squared, so 1 by 2 squared divided by 2 log of x is t plus x squared minus a squared. It's going to be t squared minus 1 by 2 the whole thing square plus c. Alright, so you get this as t by 2 t squared minus 1 by 4. You can write this as, you'll get it as 1 by 4, it will go to the denominator, so 1 by 8 log of t plus root over t squared minus 1 by 4 plus c. Next, what you can do is you can start substituting your x, okay? Your t, what did you get your t as? Your t was x plus half, right? So replace that, okay? X plus half. Okay, so x plus half. So replace this as x plus half by 2, and then this again the same thing, x plus half the whole thing square minus 1 by 4 minus 1 by 8 log of x plus half. Okay, there is t plus x plus half the whole thing square minus 1 by 4 plus c. Okay, see over here, so you'll end up getting this as, you take the LCM, you'll get this as 2x plus 1 by 4, right? 2x, this will go up. Okay, let me just continue with the step. You can proceed with some steps if you think it's unnecessary, okay? If it's not necessary, please leave them out. Now you open up this bracket, okay? In fact, you'll end up getting this as x squared plus x, okay? But for this question, let's go, okay? But remember, whatever is under this root, right? Whatever you're going to get, even if you substitute, you'll actually end up getting this x plus x squared, okay? For all the questions, especially 12, 13, 14, okay? When you solve it, whatever you have substituted, you'll end up getting the original one. But let's just go do this, okay? So this is going to be x squared plus 1 by 4, a square plus b square plus 2ab. I'm expanding it, okay? So 2 into a is x and b is 1 by 2. And do not forget your minus 1 by 4. So you just look at this, 2 cancels. And 1 by 4 cancels, right? So you're left with x squared plus x, okay? Minus 1 by 8 log of, you can take the LCM for this and solve it, or you can keep it. Okay, if it's not necessary, you can just keep it, okay? It's not really a problem. It's not necessary that you have to get the textbook answer. So you can just keep this as it is. So this is also the same thing as x plus 1, the whole thing squared minus half. So you can write this as, instead of solving it again, you can write it as x squared plus x, okay? Because we have solved the same thing over here, right? So after this, you'll get this as, you got this as 2x plus 1 root over x squared minus 1 by, no, x squared plus x, okay, divided by 4, okay, minus 1 by 8 log of x plus half plus root over x squared plus x. So we're not done yet, okay? You do one thing, write this as your equation 1, okay? Write this as equation 1. Just mark it, okay? Therefore, substituting, we already have I1 and I2. Therefore, substituting I1 and I2 in equation 1. So this becomes, therefore, what is your equation 1? Equation 1 is actually half of I1, okay, half of I1 minus half of I2. Okay, this is your capital I. So this is going to be half. You got your I1 as 2 by 3. Okay, I1 is 2 by 3 into x plus x squared to the power 3 by 2 minus 1 by 2. Your I2 is equivalent to 2x plus 4. Okay, 2x plus 1 by 4 root over x squared plus x minus 1 by 8, yes, of log x plus half plus root over x squared plus x plus c. So you can cancel this out, so you'll be left with 1 by 3 of x plus x squared 3 by 2 minus, open up the bracket for this, so half into this would give you 8, right? So 2x plus 1 x squared plus x, so 2 into 4, so you do this is 8, okay? Next thing is minus into minus will become plus, so half into 1 by 8 will give you 1 by 16 log of x plus half plus root over x squared plus x, okay? And yeah, so this is the answer, okay? You can take the LCM over here, not really a problem, okay? Alright? Okay. Or you don't necessarily have to take an LCM over here if you don't want, okay? You can take the LCM for all, or you can just leave it as it is. Not necessary that you have to get the textbook answer, alright? Okay. So we shall end this video over here.